Nature of the case, whether it's a criminal or it was a no, it was a corporate espionage or it was a tax fraud or it was immigration, that constituted the nature of the case and what kind of laws were applied and who was a judge, whether it was a single judge or a panel of judge. So if there was more than one judge, typically we saw there were 3 judges for each case, so it became a panel of judges. And the outcome, that was the variable that interested us. So what we did is initially before we started the model, we also thought let us run just for understanding what are the predictors that are important for the model, right? So we just ran a quick chi-square test for independence. We formulated a null hypothesis and alternate hypothesis, and we just ran a chi-square test, and then we just analyzed what are the significant variables and what are the non-significant variables. This was on a level of confidence level of 5%, alpha of 0.05. What we also did is, as a part of dimensionality reduction or feature selection is there's a package available called as Baruta. Actually, I'm not sure how many people have seen this. It's a package in R. Actually, it uses the random forest algorithm to give the list of important predictors. So we ran that model also, and then we just corroborated our chi-square with Baruta package to find out, what were the significant variables. So all those which are marked in green, the model is saying that, or the package is saying that they are significant variables. And whatever is in red, the model is saying they're not significant. And whatever is in blue, the model says, I cannot decide, you take a decision whether you want to include that in the model or not. So as domain experts, as people who's running the model, it becomes our call whether you want to include that variable or the predictor in the final model or not. Then after we ran this, what we did is we reorganized the entire data. Like we had created various categories. So based on the results from the chi-square test and the Baruta package, we came up with a list of predictors that we're interested in. And we also went through the data set and found out, which might be the other variables, which we feel it's maybe significant. Maybe chi-square test didn't throw that as significant, but still we wanted to include that in the final model. So we included those variables and came up with these pillars, like again the same case origin, participants, nature of the case, laws applied, and whether it was a single judge or a panel of judges. So we organize the data in this fashion because it becomes more clear for anybody to understand how the entire data set is looking. This actually took almost like 60-65% of our whole project timeline because running the model and tuning the model, that was fairly easy after we did this actually. But here is where we took the maximum number of time to decompose, understand, and since everything was coded as a number, now we have to code that into a categorical variable which we can understand. So this is where we spent most of our time on the data prep and cleansing the data before running the actual model. So I think I'll hand it over to Krishna from here. He'll take to the model and.
Thank you, Nitin. So now, as you understood, the data was complex. It was not something which was straightforward. It was predominantly categorical. It was something which we were not familiar with. Now, having done all the exercise so far, what is the next thing that we're going to do? We have to figure out which models are we going to apply. So based on all these criteria, the ones that we eventually settled down for were random forest, XGBoost, neural network, and then of course, we want to try out Ensemble too. Yes, there is a fascination, like many of us, that we fell into the trap also to say, let's concentrate on the techniques. It happens. And we wanted to try it out, experiment with it. We didn't know which ones are going to work, which ones are not going to work, and how much we would be able to tune the model. But it was definitely an exercise which we wanted to not miss out in this particular project. In the interest of time, I'm going to talk about neural networks and XGBoost. Otherwise, although we did all the 4 models as part of our project. So here are the things that we did. We first ran the model on the entire data set. As you can see, can people in the back see the slides? Is it visible with the fonts? Okay. So as you can see, the accuracy levels were pretty low when you use the entire data set. Then we said, okay, yeah, let's try to trim it, because as we did with the chi-square and the Boruta package, it indicated which ones are the significant variables. And at the same time, when you ran the model, the neural network also says which are the significant variables as well. So based on this, we figured, okay, let's trim the data set to only the significant variables and rerun it. Not much of an improvement. We just moved from 62% to 64%. Now what is the next step that we're going to do? All right, let's say our data set, when we looked at it, the distribution was imbalanced. When you look at all the different, was there a good representation of all the different kinds of combinations in the data that we used once we trimmed the model? We figured, okay, no. Then we went ahead, balanced it with the Caret package. All right, we moved up a little bit, but not enough. Then we looked at the outcome, the distribution of our outcome variable. There was one outcome which was affirmed, which was dominating over all the other outcomes. This was the reason why we thought like the model was not learning what the other outcomes are going to be like. Therefore, we said, okay, why not we do something like oversampling so that there is a good representation of all the different outcomes and run it against our model. That's where the big change happened. You can see that the accuracy moved significantly to 85%. And when we ran it against the test data set, it was at about 82%. So definitely what we understood in the process was that neural networks is one of those we should be focusing on a whole lot more. Similarly, what we did is we looked at the other three packages, which happened to be the XGBoost. Similar exercise. We went through the same kind of steps. We said, okay, yep, run it against the full model. Let's see what it looks like. Eerily, the results were very, very, very similar. But it's just that XGBoost, when we ran it against the balanced and the oversampled data sets, it gave a much higher level of accuracy. We did different combinations of tuning with both neural networks and XGBoost, and this is what we were able to eventually settle down with. I want to show you a little more details as to what this, when you look at the confusion matrix of these two models that we used. The one that I want to bring some attention to is if you look at the misclassification as to where it occurred. Right there is that you see that a good number of what the model predicted as affirmed actually happened to be reversed. So that means the model is predicting exactly the opposite of what the actual outcome was. Similarly, vacated is another one where the model thought that it is affirmed, but the actual happened to be vacated. That's something which we observed. When we look at XGBoost and we looked at the misclassification on XGBoost, again, they were very, very similar. You can see that right here, about 42 and 96 of them were misclassified, which should have been reversed. 96 should have been reversed, but the model thought they were affirmed. Now, what it's telling us is that there probably are just a few variables which are tilting the balance in there, or which is causing this misclassification to a point that you're getting a result which is exactly the opposite of this. Now, this is where we are focusing a whole lot more at this moment, like this misclassification. And what we are trying to do as one of some of the steps ahead is that try to boil this down to like a E equals MC squared kind of a formula, where you can very much simplify and then say, okay, if you can understand 2 or 3 different variables really well, you can predict what the outcome of the US Court of Appeals is going to be. That is something which we are working and hopefully we'll have some breakthrough in the coming days. Now, the lessons that we learned from all these exercises is that when you use a classification model, it is very, very important that you have good representation of all the possible outcomes. That is where the oversampling helped us in getting that balance. But there's definitely always a trade-off when you do this, something like this. Because when you're trying to interpret this and then tie it back to what exactly is happening within the model, it becomes much more difficult. When you have just the data that you received it in the first place, you can figure out, okay, what happened in there. But when you have oversampling where data is being simulated, interpretation of the outcome becomes a lot more difficult. So that is the trade-off. So this is something important that we understood in the process. The other thing is that there was a pattern in the most significant variables across all the different models that we used. Some of those were like, what matters is that the circuit code, we had 13 circuit codes which we started off with. Which circuit code is dealing with the case is a significant variable. So it can be interpreted that if you take a case to one circuit court, your chances of winning the appeal could be different where if you take it to a different court of appeals. This comes into play especially in interstate disputes. Like for example, the whole Kaveri dispute, if it had gone to a circuit court and if one party had decided to appeal, this kind of information will help them figure out which circuit court is more likely to give me a ruling in my favor. The other ones are like, what was the verdict of the previous court? If it happened to be not ascertained, mainly because the jurisdiction might be an issue, the laws applied might have been an issue for several different reasons, the lower court would have said, okay, I don't know what to do with this, I will leave it at that. If that was the outcome of the lower court, the chances of you winning the appeal in the circuit court is much higher. Nature of the appellant. There are different kinds of appellants as Nitin mentioned. So if the person happens to be a natural person, not a company or a different organization, who happens to have come under some issue which is related to the First Amendment, which primarily deals with a right of a person to protest or to have the liberty to speech, then this Court of Appeals is more likely to take up the case and give a ruling in your favor. And finally, who was the initiator? Whether it was the plaintiff or it was another party or the person who actually lost the case in the previous court. All of these are very significant factors which helps the different parties figure out whether they want to use this, go to the Court of Appeals or not. So overall, what we see is that in India's context, how does this help? Right now, there are like about 3 crore cases sitting in the legal system in India. There are billions of documents on tens of billions of papers which are in the court system. So data analytics can play a role in helping all of these. The reluctance of the legal fraternity to adopt to changes, or especially technology, is something that is going to be a challenge in Indian context. And away from that is that if you just simply use an 80-20 rule, by using data analytics, you may be able to resolve 80% of the cases using 20% of other cases as your reference. You can also look to see the 80% of the cases actually are identical. So they're probably consuming, and only 20% of the cases are probably consuming 80% of the court's resources, which doesn't make sense, and which is the reason why we have such a huge backlog of cases. By being able to cluster them or being able to classify them into certain categories, and also giving information to the parties to say, okay, what is your chance of winning or losing a particular case, the court system can definitely be much more optimized. So when you look at the Indian legal system and the quick 30-minute flavor of how data analytics can come into this, you see that there's a huge challenge, and data analytics, can it find a bigger challenge anywhere else? So you as the data analytics fraternity, are you ready to help? Thank you. So how much time do we have?
We still have 5 minutes.
4 minutes, okay. Any questions?
Yeah.
I have a suggestion as well as a question.
Mhm.
Suggestion is, when your chi-square is not giving the key KPIs or key variable for your equation, it is not because of the variable. It is because of the type of data which you align in your equation. So either you need to change your type, or you can restructure your data in a way where system can align and get a better score to get it in align with your equation. And the question is, if this is the situation which you already said, what is the solution
Solution to
to Indian environment?
Indian environment. So first question with regard to the chi-square. Yeah, we had a predominantly categorical data. And chi-square was just a reference point for us. And then when we looked at the significant variables from all the different models that were built, we compared those and then saw how much of them happened to be in common. So there was a validation of chi-square was just a starting point for us. And similarly, that's the reason why we used the Baruta package and everything else as well. So eventually,